So let's talk about some more shortcuts to prove triangles congruent. So today we're going to focus on section 4-5, which the shortcuts we're going to learn today are ASA for angle, 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 side, AAS, and HL, which stands for hypotenuse, leg. It's going to go on pages 50 to 51. The word worth knowing is included side. So the opposite of last time, so last time was the included angle, which is the angle between two sides. Today it's the included side, which is the side between two angles. So if I'm referencing these two angles right here, it's the side that touches both of those angles, which would be this one right here, would be the included side. The learning target is to be able to prove triangles congruent by ASA, AAS, and HL. So this is rounding out the 5 ways or shortcuts we can use to prove triangles congruent. You can always go back to that 6th way of using definition of congruent triangles, but I don't know. I wouldn't choose that because they're really long with those 6 pieces of information that you need. So we're going to focus on sticking to 3 pieces of information, and even though HL looks like it would be 2, that's actually 3 pieces of information, which we'll talk about in your notes. All right, so you will need in your green packet, you will need this set of notes right here. You just fold it in half and cut along the top layer again. This should have ASA, AAS, and HL on the front. So go ahead and take a moment to get those notes, fold them in half, and cut that top layer to get ready for our notes. You may also want to have this paper as well. Remember, this is our resource for proving triangles congruent. So we are also going to use this paper again today. So I'm just going to have it off to the side. Okay, so let's go to the paper first, actually, that resource. So remember, just a reminder, this front side reminds you to always mark your picture with the information you're stating in a proof, to use your given information first to get some new information about sides or angles being congruent. Once you've used your given, you're going to look to your picture, possibly if you need a third piece of information by either a shared side or that bow tie looking, which is always going to be vertical angles. And then once you have your 3 pieces of information, you're going to stop and check to see if you can prove them congruent. So last time in section 4-4 we covered side, 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 and side, angle, side. Today we are going to add angle, side, angle, 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 side, and HL. So these right here, these 3 are covered in your 4-5 notes. Okay. Now there's a reminder there. Don't worry about that right now because it probably won't make much sense, but we will get to it. I want you to think about the combinations that are not here. Okay, so notice how we have a side, 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 but we do not have an angle, angle, angle. So you may already have figured this out, but angle, angle, angle does not prove triangles congruent. Okay, so A does not prove triangles congruent. And the reason why is, let's think about an equilateral triangle, because an equilateral triangle is equiangular, which means all the angles are 60 degrees. Okay, so I could have an equiangular triangle with side lengths 1, 1, and 1, right? So that's just a little triangle there. All the angles are 60 degrees, but they are congruent. I can mark them congruent. But does every equilateral triangle have to have side lengths of 1, 1, and 1? No. So you could have a dilation, or basically you're scaling that triangle bigger, so you're just enlarging it, but you're enlarging it so that it's proportional. So the side lengths will all change in the same way, so it doesn't alter the shape. So it would still be 60, 60, and 60 degrees, but this could have side lengths of like 3, 3, and 3. So that's just one example of why angle, angle, angle does not prove two triangles congruent. You may also see here that there's no naughty words. So I know that you can create a naughty word using a combination of these letters. So no naughty words will prove triangles congruent whether spelled forwards or backwards. So no ASS and no SSA will prove triangles congruent. Okay? So anyway, just to have that complete, now we'll go to our notes. Okay, keep this handy. All right, so let's go ahead and do exactly what we did last time. So I'm not going to write this out in words. I'm just going to show you kind of in picture format. So angle, side, angle, or ASA stands for angle, side, angle. And AAS stands for angle, angle, side. Okay, so you'll notice how there's two sets of angles and one set of sides. The biggest difference is the placement of where the side is located. So notice how this one right here, that side is directly between those two angles. So this is the included side. And this side is not included. Okay, so that's a not included side, or a non, I guess I should have said, non-included side. All right, so let's see what that would look like in a picture. So I'm going to attempt to draw two triangles congruent. Ooh. Imagine that those are the same. I know they're not exactly the same. Okay, so I have to know two angle pairs are congruent. So angle congruent to angle, this angle congruent to this one in corresponding places. Now I already know that that third angle will be the same, right? Because of third angles theorem. So that means that these two triangles would have to be similar. So you have to have at least one side length the same in order to prove that they're congruent and not just a scale version of the other. So let's say I have the included side, which would be this side, would have to be congruent to this one. Okay, so if you have this information, then you could prove those two triangles congruent by angle, side, angle. I don't have enough room to write it, so I'm just going to show you visually there. Okay, now let's look at angle, angle, side. So I'll draw a couple different triangles. Okay, again, I'm going to attempt to draw these the same. It's okay if they're not exactly the same. Okay, I need two sets of angles. So let's say I know this angle is congruent to this one. This angle is congruent to that one. Okay, again, I know those third angles would have to be the same, okay, so that these would be similar. But I would have to know at least one side length is congruent in order for them to be congruent and not just scale images of one another. So this one is the non-included side. So it doesn't matter if it's this set of sides or this one. It just would not be the one directly between. So I'm just going to mark this one congruent to that one. So notice how it is not directly between those two angles. So if you have that information and they are corresponding in the same place, then you can prove the two triangles congruent. Okay, let's go ahead and try a couple problems on the inside. So we're doing a couple proofs here. Okay. And here we're going to do, I think for these ones, it's like we can prove it using any of the ways. It doesn't necessarily just have to be angle, side, angle, and angle, angle, side. It could be side, 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 and side, angle, side as well. So we're just going to kind of wrap them all together. So here, this got cut off. This is a K up here. Sorry about that. Okay, so first thing, I always use the given, but I can be consistent from last time, and I can highlight the triangles I'm trying to prove congruent. So I'm trying to prove this triangle right here is congruent to this triangle right here. Okay. Now I'm going to start with my first piece of given, which is segment JL bisects angle KLM by given. Okay. So I have something that bisects an angle. So whatever comes after the word bisects is what's cut in half. So you can look in here, and it says angle bisector. You could state that two angles are congruent by definition of bisector. But here I just know that whatever comes after the word bisects is what's being cut in half. So if I look at angle KLM, that angle is being divided equally. So I could state that these two angles are congruent by definition of angle bisector. So here my reason is definition of bisector. Okay. And here I need to name those two angles, which I'm going to use 3 letters to do because there's multiple angles at L. So I'm going to say angle KLJ is congruent to angle MLJ. By definition of bisector, I've already marked it in my picture, and I'm going to put an A for a set of angles. So I have one piece of information. I'm going to go back up to my given. Okay, we'll cross that off. Go back up to my given and pull the next piece down. So angle K is congruent to angle M by given. That's a congruent statement in and of itself. It's angle, so I'm going to put an A here. I'm going to mark it in my picture. So angle K is congruent to angle M. And I'm using two different arcs because those are different angles than the ones I've already put in there. So now I've used all of my given information, but I only have two pieces proven congruent. So I need to go to my picture. So remember, on this back side, you can go to your picture, and it's either going to be a shared side or vertical angles. So in this case, we have that shared side. Okay, so you can see they kind of butt up next to each other at JL. So I can state that segment JL is congruent to segment JL by reflexive property of congruence, and that was a side congruent. So now that I have three pieces of information, I want to come down here to this paper and see which of these ways I can prove it congruent. So I have two angles and a side. So it's either going to be the sides included or it's not. So if I look here, this side is not included between those two angles. So I could prove it by AAS because it's a not included side. Okay, so I could say triangle JKL is congruent to triangle JML. And the reason why is because that side is non-included. Okay, non-included side. That's why it was AAS versus ASA. Okay, let's do another one. And you can always pause this and try it on your own. I would highly encourage you to do that because the goal is for you to be able to do these proofs by yourself eventually. But I am here to help you in the meantime, okay, and in class too. All right, here we go. We're trying to prove this triangle KLN is congruent to MNL. I'm going to start with my given information. First piece is that segment KL is congruent to segment NM by given. Now this is already a congruent statement and it's a set of sides. So I'm going to do an S here and I'm going to mark it in my picture so I can visually see it. So KL is congruent to NM. I'm going to use my next piece of given. Now you could just put a comma there and put them together because they're back to back, but I'm just going to separate them. It's okay either way. So I also know that those segments are parallel. So segment KL is parallel to segment NM by given. Now that's not a congruent statement, so it doesn't get me a set of sides. But I know from the sheet right here that whenever I am given parallel, I want to look for alternate interior angles. Okay, that's my goal, look for alternate interior angles. And I want to use that Z format. So remember, this is the transversal. So if I go side, transversal to side, you'll see how it outlines this angle right here, kind of at L, and this angle right here at N. So again, I just went side, transversal, side, just to connect them. So now I'm going to name those two angles using three letters. And remember, that's by alternate interior angles theorem. Okay, I'm going to state a pair of angles congruent. So I'm going to say angle KLN is congruent to angle MNL by alternate interior angles theorem. Okay, use that given. I have only two pieces of information. So again, I have to look back at my picture right here, getting these two things. So hopefully you're getting these now without looking at this, but if not, just keep using this for now. So here I have a shared side again, okay, because they kind of butt up to each other right there. So I know that segment NL is congruent to segment NL. So I'm going to state that by reflexive. Reflexive property of congruence. That gave me a set of sides. Now here it's SAS, but remember we need to check the order in the picture. So if I look at that blue triangle here, I have two sides, and that is the angle directly between them. So then it would have to be the same for this orange one. So I have the two sides and the angle between them. So I can prove those by SAS. So again, remember, it could be any of them at this point. So here I could say that triangle KLN is congruent to triangle MNL by side angle side. Okay, so the goal, use your given and your picture to get 3 pieces of information, then stop and see if you can prove them congruent using one of these ways, the shortcuts. Okay, so the only one we haven't talked about is HL. And to be honest, HL is the one that kind of confuses people the most. So I want to kind of just take a little Post-it note here and remind you about something. Okay, so if you have a Post-it note, you can do the same. So HL, actually I'll just write part of this down here, stands for hypotenuse, leg. Okay, so a hypotenuse refers to a side of a right triangle. So this right here is only for right triangles. So I'm going to put that in capital letters. Only for right triangles. Okay, that is very important. Okay, they're only for right triangles. And the reason why you can state that these are congruent for right triangles is this. So let's say I have, actually, yeah, I'm going to review a little. You don't have to write this down. Okay, so let's say I have a right triangle and I know 2 of the side lengths. So let's say I know this side is 3 and this side is 5. So I know the hypotenuse and I know a leg. Okay, so hypotenuse is the side across from the right angle, and I know the leg. Okay, there is something that you learned in middle school math, maybe even in late elementary school, called the Pythagorean theorem, which is a squared plus b squared equals c squared. Okay, it is a theorem that is only for right triangles, like this, and it states that if you know 2 sides of a right triangle, you can use this equation to solve for the third side. So I could use this Pythagorean theorem, plug in 3, okay, so the hypotenuse always has to be c, so I could do like a, b, and c, and I could plug this in and solve that a would have to equal 4, okay? So I'm just jumping to it. I'm not showing you the work yet. We'll cover Pythagorean theorem later. But what's important is that if you know 2 sides of a right triangle, the third is already determined. So it doesn't matter what the 2 sides are. The third one will always be able to be found using the Pythagorean theorem. Okay, it is set. Okay, it cannot change. So that is important to why this works. Okay, so you can set that aside for now. So with this one, I'm going to draw my 2 triangles. Okay, they're going to be right triangles. Okay, so this one I'm going to use a checklist. Okay, so the first thing you have to know is that they are right triangles. Okay, that's the first thing you're going to check. Right triangles, question mark. So here they have a right angle, then they're a right triangle, check. Okay. The second thing is you need to have a hypotenuse of one triangle congruent to a hypotenuse of the other one. So I'm just shorthanding them HYP. So that's the longest side. So I'd have to have this longest side congruent to this one. So I have the hypotenuse congruent to the hypotenuse. And then you have to have a leg congruent to a leg. So a leg congruent to a leg. Now here you have to have them in corresponding places. So that means just in the same spot. So if I had this side congruent, it would have to be to this side. So that is, if I know these 2 sides in a right triangle, if I use the Pythagorean theorem, I'd get the same side length for this one over here. So it would force these 2 triangles to be congruent. But it only happens for right triangles. Okay, so check, check. So the one thing that's kind of tricky on this one is in your proof, okay, I'm going to put this as like a little star, you need to state the triangles are right in your proof. So it's an extra step. So there's still 3 things you need to state before you stop and prove the triangle's congruent. So in this one, you'd have to have the hypotenuse statement, the leg statement, and that it's a right triangle. So these 3 things you'd have to state in your proof in order to use it, okay, as HL. So I'll show you. But before we do that, we're going to do this one. And it's determine if you can use HL to prove the triangle is congruent. If not, tell what other information you would need. Okay, so this one I am going to use a post-it note here in a second for the second one. So I'm just going to quickly redraw. Because when I draw my picture, I don't want it to be confusing. So I'm going to do it 2 different times. Okay, so I need to do my checklist. So I'm going to have my little checklist over here, the 3 things. So I want to figure out, are they right triangles? Do we have hypotenuse congruent? And do we have legs congruent? Okay, so that's my little checklist I'm going to use for each one. So here, determine if you can use HL. Given this information to prove, I'm going to highlight. So this one right here, triangle VWX, so VWX, so this triangle right here, congruent to YXW, so YXW, so this triangle right here. Okay, so we're going to see if we have enough information to prove those 2 triangles congruent for this first one. Okay, so here I already have one side congruent, so that's the leg. So I can go leg, yes, check, right? Here I know it's a right triangle because it's a triangle with a right angle, so check. So the only thing I'd need to know is if the hypotenuse is congruent to the hypotenuse. Okay, so I gotta find where the hypotenuse would be, which is always across from the right angle. So if I look across from the right angle, I would need to know that this side is congruent to itself, okay? That is true because that's the reflexive property, right? They share that side right there. So that would be true. So I would know the hypotenuse is congruent to the hypotenuse. So yes, I could use HL. Okay. Now I'm going to do the second one. I'm going to do on my post-it note right here so I can shade it and you can see it really clearly. So in this one, I'm looking at VWZ. So this triangle here. And I'm seeing if I can prove it congruent to YXZ, which is this triangle right here, by HL. So again, I would want my 3 things. Right triangle, question mark, hypotenuse congruent, question mark, leg congruent, question mark. Okay, so here I still have the same 2 things I had up here. I know that they're right triangles because they're triangles with right angles, and I know there's a leg congruent. So I would have to check the hypotenuse. So the hypotenuse of each triangle would be this side, would be congruent to this side. So I can't determine that visually, right? It's not a shared side. They're not vertical angles, right? Those are the only 2 things I can get just by looking at it. So this one I would not have. So this would be not enough info to use HL. So that one, because I don't know the hypotenuse are congruent, or the hypotenuse are congruent, then I could not use HL. Okay. All right, last one here. I'm just going to fold this up. Okay, triangle ABC. Ooh, that was rough. I was having a rough day when I drew that picture. Okay, so I'm trying to prove this triangle right here congruent to the one next to it. Again, I would want my checklist of the 3 things. So right triangle, question mark, hypotenuse congruent, question mark, leg congruent, question mark. Okay, so here The right triangle is pretty easy to see because I just have the triangles here. They both have a right angle. So check. Okay, hypotenuse congruent. So here across from the right angle, this would be the hypotenuse. Congruent to across from the right angle, that's the hypotenuse. So check. And then I would just have to see if there's a way I could state that a leg is congruent to a leg. So this one, there's a shared side. Okay, so here I could state that that's congruent to itself by reflexive. So that gives me a leg congruent to a leg. So yes, I could use HL to prove those two triangles congruent. Okay, so I just wanted a little bit of practice identifying if you could use HL because it is a bit trickier than the other 4 options. Now let's see how it plays out in a proof. This is the last thing we're working on. All right, this one's going to be a little bit longer. So just so you know, there's going to be 6 steps that I do here. Okay, I'm trying to prove, you could probably guess, this triangle right here, oh no, it got cut off, is congruent to this triangle right here, and that would be a C up here. So if that were on the paper, there would be a C at the end of that triangle. So step 1, I'm going to use the given. Now I'm going to take the first 2 pieces of given and put them together because they are similar statements of information. They are both stating that segments are perpendicular. So I'm going to do segment AB is perpendicular to segment AD, comma, segment AD is perpendicular to segment CD by given. So you can look at this, right, and you could say if there's perpendicular, the next thing you can do is you can state that angles are right by definition of perpendicular, okay? So I'm going to state which angles are right, and I actually already put them in my picture. So here, step 2, I'm going to just say angle A and angle D are right angles. Okay, so here angle A and angle D are right, and I know that by definition of perpendicular. Okay, now remember our checklist. Our first thing is we need to know that these are right triangles. So once you have a triangle with a right angle, I can state that these are right triangles. Okay, so here I can say triangle, and I'm just going to use the way they write them here, triangle ABE and triangle DEC are right. Okay, and that would be by definition of right triangle. Okay, by definition, if a triangle has a right angle, then it is a right triangle. Okay, that is also on your reference sheet right here. Right after you state angles are congruent, then you can state triangles are right. Okay, all right, so I have that first part of my checklist. Check. Okay, so now let's keep going. I'm going to go back up to the given, okay, and use the next piece. So in step 4, I'm going to do E is the midpoint of AD and BC by given, and cross this out. Okay, so I've used all my given, but I still need to use this piece to get something else out of it. So knowing that it's the midpoint, the next reason is going to be definition of midpoint. Okay, so a midpoint divides a segment in half, so I can state that 2 segments are congruent on each side. So I'm going to look at each one. So I know E is the midpoint of AD, so I could state that AE is congruent to ED. So segment AE is congruent to segment ED, comma, it's also the midpoint of BC, so I can state that BE is congruent to EC. By definition of midpoint. Now, I have 2 congruent statements here. Those are 2 sides, but let's look at the picture. AE and ED is the leg, right? So I have the leg. And then BE and EC, those are the hypotenuse, because it's across from the right angle. So that would also be H. So I have the right triangles, I have the hypotenuse and the leg, so I can stop. That's enough information to state that the triangles are congruent. So I can see triangle ABE is congruent to triangle DEC by HL. Whew. All right, so now we've covered just all the shortcuts for proving triangles congruent, and we will practice together in class. See you soon.